Debbie Smith. Debbie has been with BRE for many years now, and her role as Director of Fire Sciences, and she has been involved for many years with all sorts of testing. And we can read, I won't read this out, but I will hand over to you, Debbie, and for you to give, the title of your talk's far too long as well. I won't go down there. Debbie.
Okay, right, thank you very much. Thank you, Dougal. I've sat here today and listened to the previous speakers, and I have to say that a number of the issues that I've got addressed on the following slides have already been picked up by a number of the speakers, which is quite useful in one way. And interesting in others. At least we've got some kind of common areas, common understanding, and common needs going forwards. But one graph that nobody has shown yet is the trends in fire deaths in the UK since 1981. I retrieved this from the UK fire stats and thought it was just, as we were asked to look back over the last 40 years, it was quite a useful trend diagram to put up. The area that BRE has worked in for many, many years, not predominantly or entirely, certainly in most recent years, but since I joined, has been on life safety issues. We've done lots of work, lots of research, etc., focused on saving lives in support of the building regulations and the approved documents, etc., that are used within the UK regulatory framework. So one of the key performance indicators for that, if you like, is a graph like this. How many people have been dying in fires, and then we try to review the statistics to understand why, what's going on with the trends. So this is quite interesting in that you can see back in the early 1980s, around 1,000 people a year were dying in the UK in fires, and we're now down at a level of around 380 with the latest version of the fire stats. So some things have been happening, some things have changed, and the trend is a good trend, which collectively we must all be doing something right. However, there's never any room for complacency, and as I'm going to mention in a few minutes and other people have mentioned, there's many challenges ahead of us, many new things that are occurring that we have to be able to address. So what kind of changes, what kind of factors have occurred during that time? Well, obviously there's many factors and there's many interacting changes that have occurred that have contributed to those statistics that I showed. But perhaps some of the key ones that are worth just highlighting are firstly smoke alarms. Back in 1988, the penetration of smoke alarms in the UK in the built environment was about 8%. Today, or not today, in 2008, that was 86%. So that's quite a major factor in terms of obviously alerting people to a fire to enable them to escape. And that's one of the key factors that has contributed to the trends that we have seen. Another factor that has been spoken about in various fora in the past was the introduction of the furniture and furnishing regulations in the UK in 1988. On the back of a number of high-profile fires in dwellings where people were losing their lives because of the speed with which the fires were developing, and involved within that was upholstered furniture, the decision was taken to introduce some more stringent controls in terms of the fire safety of the furniture that we buy and put in our homes. So some test methods were developed, and all the furniture that you buy currently today has to pass these various tests. Of interest is the fact that this regulation is currently under review by the government. One of the factors that's driving that review is the fact that the European Union is banning lots of chemicals and different substances, which is making it harder for the fire retardant industry to come up with solutions, ways of treating the furniture to ensure that it passes these tests. So one of the possibilities that we're looking at in the not too distant future is a relaxation of this particular rule, this particular regulation. We don't really know what the consequences of that would be. Speaking to a colleague earlier today who was saying they believe that there's a technical robustness to what's being proposed. I don't think, certainly from our perspective, that's not been well enough publicised and reviewed at this stage, so the jury's out. Changes that have occurred that we don't know the impact of yet, that are not clear, are things like reduced ignition propensity cigarettes. That's a measure that was introduced in the United States first, and it's now travelled the Atlantic, and it's now being implemented throughout Europe. In all the EU countries, whether you're a smoker or not, you may not know, but the cigarettes that you now buy are self-extinguishing. The idea behind that is that they will not act as an ignition source. The expectation is that they will have another positive effect on the fire statistics, but we have to wait to see if that's confirmed. And then another factor that's, again, we don't quite know what the outcome of it will be, was the introduction of construction products regulations in 2013. Patrick touched on it earlier in terms of the introduction of new fire test methods for evaluating the performance of construction products. Obviously, when you introduce something like that, it's not a like for like. You've based your regulations on certain characteristics and performance parameters. You're now changing those, and you will not get direct comparability. Will the impact be positive, be negative, or will it be level playing field? I think there will be some perturbations. We have to wait and see what the overall impact is. So, our world then is changing, and it continues to change, and it will continue to change. We're seeing lots of changes in building technology. That's the way buildings are built, the materials that they're built from, and so on, as has already been spoken about today. We've moved away from more traditional types of construction, more lightweight, easier, faster to construct systems and products. And the drivers for these are coming from non-fire related areas. Again, as mentioned earlier, the need to reduce energy consumption, reduce waste during construction. There's a focus now on end of building life, environmental impact, what you do with a building when you deconstruct it, etc. Where are you going to dispose of it? Are you going to recycle some of the materials? Are you going to reuse them? All of these things are now coming to the fore and are being considered much more seriously. So, examples of some of the types of things that you might be seeing now. I mean, the picture on the top left there is basically a system that is designed to look like traditional brick and mortar build. Actually, what you have is a plastic carrier plate over the top of a combustible insulation, and within that you grout in tiles of brick, which are called brick slips. It performs very well. If you tested that in a standardised test, it would do very well. It will achieve a Euro Class B, or in the UK's old money, a Class O. The picture next to it is the effect of a fire in one of these types of buildings, where you can see the fire penetrated through that, and it all ended up on the floor at the bottom of the building. One of the issues with these types of systems, if they're constructed properly, they will perform well. If they're not constructed properly, they're more susceptible and more vulnerable to poor installation. We're also seeing, obviously, lots of new technologies that are being incorporated into and within buildings. PV panels are being installed on roofs of buildings. This is a domestic dwelling, but they're going on to commercial properties now. The government in the UK is incentivising people to use large warehouse roofs, etc., for PV panels. There's a potential there, a new potential risk that perhaps isn't being as well controlled as it might be. Again, the picture on the bottom left, just very quickly, is again showing the susceptibility of the types of construction that we're using now to damage. They're much more susceptible and much more vulnerable than perhaps traditional construction was, and there's more of a need for ongoing maintenance of these systems. So, what issues do we face now and going forwards? Well, with all of these new innovations, we don't have any historical database. There's no statistics that we can base any new regulations on or any new assessments. We're starting from really a really low base of knowledge. There's the possibility of systematic faults, poor quality of installation, use of new materials, in particular, and I think Barbara mentioned it, highly insulating combustible materials being used to reduce energy demand, new test methods for benchmarking, new requirements for air tightness in buildings, levels of safety and property protection that we have no benchmark for, and then the possibility of disproportionate damage. Very small fire incidents can result in quite significant property damage and business continuity issues. This is just a graph that I extracted from one of my colleagues' reports that he's just produced, actually, which is summarising the impact of insulation on compartment temperatures. So the red and the blue lines are the lines that we're currently using for design calculations. The blue dots that you can see are data extracted from some experiments that were carried out on better insulated compartments. With U values, and the U value is the metric that's used to characterise the insulation performance. So for those, the U value was 0.8 to 3. The current building regulations in the UK now require U values between 0.16 and 0.28. So significantly greater levels of insulation for which we have no data at the moment. So one question is, are the design methods that we're using relevant to the types of buildings that we're now building and constructing? So opportunities then in relation to research. We shouldn't see these things as blockers and negative things. We have the background and the tools that we need. I think you've heard about the developments in the modelling and the means of testing things as systems. We have the means to assess the impacts, support the innovation and resolve the challenges that they are facing and they are posing to us. We need to be looking at maintaining and improving the safety levels. We also have to focus on reducing fire losses from property damage and business interruption. What I'm going to show now is just a very, very quick overview of a case study of some work that we've recently undertaken, which is looking at treating the fire safety issues in a holistic way. We're looking now at assessing the sustainability contributions and aspects in relation to fire and fire performance. So we've considered within this study things including the environmental impacts, the societal impacts of fire, and the economic impacts. And given all of those factors, you're not just looking at the life safety, you can then look at things like the property damage, the business interruption content, and you can start to assess the costs and the benefits of different fire protection options that are available to you. So this particular case was for sprinklers in warehouses. So Lou spoke about the work that FM are doing with warehouses. This project was funded by something called the Business Sprinkler Alliance in the UK and involved a lot of key stakeholders and data from a number of different sources. And it set about to consider both the environmental impacts and monetary costs and also the whole life cost benefit analysis for installing sprinklers in different sizes of warehouse. this was quite unique in that this was the first time anybody had tried to do this. There's life cycle analysis tools that are routinely used in certain sectors for assessing sustainability, but they've never been brought in and used in conjunction with the overall assessment of fire and fire performance. So initially, our colleagues who are experts in this area undertook a cradle-to-grave analysis of the warehouses, the model warehouses that were chosen for the study, and looking at the installation of sprinklers within those. So with that, you go through a process of assessing the impacts, you analyse, you normalise, you weight, and then you convert it to something called an Ecopoints value. The contents for the warehouse were similar to the types of contents that BRE Global use in lots of their analysis. So it's cardboard cartons with polystyrene cups within them, and the fire loading was assumed to be 75% of the total warehouse capacity. And you build up a picture of where the different contributions to the environmental impact come from. And that's what that graph is showing. And it won't come as any surprise. A warehouse with a sprinkler system obviously has a greater environmental impact when you just look at it in terms of the build, because of the extra materials and all of the different factors. And I don't suppose you can read those, but they are all the different elements that were considered as part of this study. So what then happens with that is that data is then taken and is looked at also within the context of the fire. If you had a fire in a warehouse, you then look at the impact that the fire would have on the environment. So in the case where you have no sprinklers, obviously the environmental impact is greater, and then you pick up the benefits from having a sprinkler system. Obviously that is true in the cases where you have a fire. The other part of the analysis into which that analysis fed was the whole life cost-benefit analysis. And for that, we looked at 3 different sizes of warehouses. The frequencies of the fires were estimated, and they were estimated from the statistics that were available, both in the UK fire stats, and also we worked very closely with the insurers, looking at their data and their databases to give us the loss information in terms of monetary values, which extended to business continuity, etc. The one thing that came out of that is it's very difficult. Lots of people collect their own statistics for their own purposes. Nobody ever stops to think, does this data set talk to this data set? How easy is it to correlate them? And a large part of the work involved in this project was trying to unpick the data, even when you knew you had a major fire in a major location on a major day, to try and correlate the 2 databases and get some meaningful data proved extremely difficult. And you might say, well, that just sounds stupid. I mean, it sounded stupid to us. But I think a lot of lessons have been learnt, and hopefully going forwards, that's one area that will be addressed. We can have some common interpretations of data, we can start to have some common formats, and we can start to make this type of analysis much more routine and simpler. The consequences of the analysis and the fire then were expressed in terms of fire and smoke damage, deaths and injury, CO2 emissions, and the embodied carbon dioxide within the constructions, water usage, and unemployment. So one of the societal impacts and the knock-on effects. If a building has a fire, very often the business ceases to be, and it can have a knock-on effect in terms of unemployment. And the Monte Carlo method was developed, which is a probabilistic type approach, was developed and applied to the problem. So very quickly then, in summary, the results from this study, and the important thing to realise here is these are average costs across the whole of the warehouse range for that particular size, and you can see that for the small warehouses the cost of the cost effectiveness associated with no sprinklers the costs are greater for no sprinklers, and you can see, so that's the bottom line here in blue, the total costs. Okay? So the whole life costs, and this is where it's averaged over 45 years, which is considered to be the lifetime of the sprinkler system. You then start to see where the benefits are, and you can see that the total whole life costs along the bottom for the smallest warehouse size, it's not cost effective to install sprinklers within those buildings. But for the other two sizes of warehouse, it is cost effective to install sprinklers. So one of the questions that then follows from that is, why then do we not change the building regulations? Why do we not make that a requirement? The answer to that is nobody or very few people actually die or get injured in fires in warehouses. It's about property damage and business continuity. So this is a decision, this data is available in the public domain, and it's a decision that is taken by the building owner, the occupier and the insurance company to decide whether they want to invest that money for the benefit of their business going forward. Okay, I've covered that. And I've covered that already. The web address at the bottom there is the full report is available if people want to know, in great detail exactly what was done. It's about a 130-page report, so I've just really skimmed over much of what was done. So finally, just bringing this now round to a conclusion in terms of what we do and why I'm here, I guess, today. It's important that we invest collectively in solving the fire protection problems, and the best way to do that, obviously, is through research, and it's through collaboration. No one organisation or one individual can solve the world's problems on their own. And in 2003, BRE set up what was our first University Centre of Excellence here at Edinburgh, and the BRE Centre for Fire Safety Engineering. And that is funded by the BRE Trust, who owns BRE and what was the Fire Research Station. So that's a charity. BRE Trust is a charity with a mission to promote and support excellence and innovation in the built environment for the benefit of all. And it does that through supporting research and education. They've provided the funding to support the Chair of Fire Safety Engineering here at Edinburgh, and the first incumbent of which was Professor Jose Terrero, and now very pleased that Albert Simeone has joined the team here, and he is the follow-on chair. We've also funded 12 PhDs to their conclusion during that period of time, and the reason the Trust is doing that is really they see these as the next generation of leaders in the field going forwards. So I say it's very important, and I think the fact that Arabs are also supporting the centre here is, of great benefit and great strength to the fire engineering community here in the UK. And hopefully it's something that will continue for the next 40 years. It won't be me that's here at that celebration, but hopefully there'll be some young person stood up here that's following on from that. So thank you very much for the opportunity of speaking here today. I'm happy to take any questions. I would like to just mention colleagues who obviously carried out some of the work here that I've presented, and who were authors of that report that I put forward. So thank you very much.
For a very interesting presentation. Any questions? I think we can afford a few moments.
Everybody's tired.
Oh.
Sorry, which one? Yeah, it's pounds.
per square meter?
No, it's pound.
For the whole building?
Yes, yeah, within that range. So it's the average over that size range. So 2 to 10,000, it's the average over the 2 to 10,000 square metre range. Okay.
I might just point out that David Rasbash was very exercised by the issue of getting statistics out of the individual insurance companies so that they could be compared across the board. We just weren't interested.
Yeah.
And Ron Hurst did exactly the same, or tried to do exactly the same for the chemical industry, but he didn't get very far.
Yeah.
More
Well,
collaboration is...
Yeah, they are collecting the statistics now through the Risk Authority. But as I say, there's a lot of work to be done to make them all consistent and easily usable.
Any other questions? Well, I'll ask you once again just to thank Debbie. I'd like to hand over to Luke Bisbee once again just to wind the afternoon up.